We'll go to the machine learning. So here in the machine learning, we have so many different type of things. First, you have to understand. So in the foundation level, you have to understand what is supervised and unsupervised learning. So you know that what is supervised and unsupervised. No idea. Supervised is nothing but labeled, unsupervised is nothing but unlabeled data. So yeah, we'll discuss that in deep once we started our course. So supervised versus unsupervised, and also how you are going to split the data, like training and testing, and also we'll go with overfitting, underfitting, and we can do the cross validations. So we have to do a lot of things in ML foundation level. So first of all, you have to understand some theory part on it, what is supervised and what is unsupervised, and how the training versus testing will work, and other things. And then based on that, we'll go with the framework basics. So this is for coding level, and I told you right. So where we also get some understanding on low code, no code environment before we entering into the coding. So for that, we have two different tools called Orange and Vika. So first, we can take some understanding from those two softwares, where we can find out. You have to first understand whether it is a classification model or a clustering model, and then you can go with the classifications and clustering techniques, where we can talk about if in the classification we'll talk about uh, different type of models like KNN, navy base, a tree structure like random forest, and some other algorithms on that classification level. And coming to the clustering, so where in the clustering we'll go with k-means cluster, db scan, and hierarchical clustering. So these are the clustering techniques you can use, and uh, understand those environments. And coming to the frameworks basics, where once you got some understanding on all these theory parts and low code, no code environment, then we'll enter into the frameworks. So where we will use TensorFlow and Keras. So these are also required for the machine learning. So using scikit-learn, Keras, and TensorFlow, you have to understand these three frameworks, how to build and deploy the ML models efficiently. So once you develop the framework, then we'll talk about the whatever the core algorithms I was talked already, algorithms related, where for the predictions we'll go with the classification, and we'll go with regression models. We'll have the regression analysis, and also we'll go with the decision tree for interpretable models. So the decision trees are nothing but the random forest, J48. So these all comes under a tree structure. So this decision trees will work on particularly on this core algorithms. And coming to the advanced methods, where we'll go with k-means clustering. That's the clustering techniques. So where clustering. So you have to form a cluster. So you have to understand what is outlier, and once you have to understand all these things, you can able to get some understand, get at least 50% of machine learning. You can able to achieve it via these four things what I have mentioned here, like foundation, and also we'll talk about low code, no code environment, framework basics, core algorithms, and advanced methods. So using these four, you'll able to understand at least 50 to 60% of machine learning. Then you have to put your efforts, and that means you have to train yourself, or you have to go and pick your data set and practice yourself. So you have to gave more practice on machine learning. So even machine wants that, because if you are taking a data set and if you are trying to build an AI system, so that first itself it will not give you a 90% or 95% of correct predictions. So it will give you correct predictions, maybe initially 70% or 60% based on the data you have selected. And if the data is too worst, it will give two worst results. So that you have to understand. So for example, here predicting house price to classify images, we have so many different type of classification related and prediction related uh, like examples. I can give you one of the example that whether the person is loan worthy or not. So for example, I just want to create a system where that system can predict if a new person come here and I have a bank, so come to that bank and ask for the loan. I will just to understand whether he can repay the loan or not. So for that, I have an AI system. That AI system, if I provide him, like if I provide the AI the customer details, it will fetch the customer old details, like for example when he is having any additional loans past, he has a few of the loans are not paid on time, and his CIBIL score is not good, and he also having a lot of uncertainty in their work. So for example, he is not working in the company more than an year or less than a year, and he is shifting the companies, and he is waiting for 3-4 months for that to shift the organization. So these are the clauses I can take, and based on that, can I provide him a loan or not? So that's a system we can have. And also we can, if it is in the banking system itself, we can go with another kind of application that, like, predicting, so loan worthy or not. So this is maybe yes or no kind of things, like that is a boolean kind of variable we are expecting. So that is what the classification do. So the classification problems will mostly work on this kind of yes or no systems. And also coming to the another banking example where we can find out the transaction is fraudulent or not, is fraud or not. So that fraud or not kind of, and also predicting loan worthy or not. So these are the examples for classification problems where you can understand, you can collect the different type of data and train your model on that particular data and give you a new user details, and it should predict exactly. So that's the system machine learning and AI systems work on, this kind of approach.